As we continue with section Unit 3, it's where we've covered a lot of the basics, we've covered a lot of the extension, but it's still just some more problems to see how we apply these ideas. So far what we've been doing, we've gone through the different quadrants, pointed out the pluses and the minuses, how to apply them. We've done a lot of problems so far, just confirming what quadrant we're supposed to be in based on some plus and minuses, and then being given a trig value and some information to be able to find all the other trig values. And we could do more of that. So let's just keep going. Let's do two problems that seem a little different, but are really just more of the same. So the next one, let's consider we are given the information that theta goes through the point -12, +5. Let's evaluate all the trig functions at theta. Again, exact answers. I keep saying it. If you are trying to use your calculator to find theta and then use your trig buttons, you're going to get decimal approximates. You're not going to get full credit. So again, the exact answers in some way, shape, or form, it's about either using trig facts, identities, or right triangles to get the values. And that's how we get the exact answers. Like the previous problem, we had answers like 2^6 divided by 7. Again, if you have to do that on a calculator, you're not going to get such a, I'm not going to say it's a nice fraction, it's a little ugly, but it's a clean fraction. Your calculator, you're going to get an ugly decimal approximate, and that's not what we're looking for. So same thing here. So this may look very different compared to the previous problem, but it's still incredibly similar. Previous ones, we were given a trig value, positive or negative, but we had to do a lot of the thinking about which quadrant we were in based on that information, and then make the right triangle to get the remaining values. This is a spot, some might argue, those extra definitions of looking at the trig values without the unit circle might help you a little bit here, but I just still think that's a lot more memorization, and it's just really not fully necessary. So let's try and see how to do it. In my opinion, an easier way for all. So first thing, let's draw this out. If theta goes through this point, well, where is theta? If you go -12, 5, you went left and then up. So theta goes through that point, meaning there's your theta, and we're in the second quadrant, right? -12, sorry, that's a comma, not a point. -12, 5, so I went left 12, up 5. So now I know I'm in the second quadrant, and I could already jump into my right triangle. But this is where, when I make the right triangle, well, first thing, make sure you go to the x-axis. Make sure you consider this the reference angle, which goes to the x-axis. That is the angle you care about. And then how do you fill in these values? You went left 12. I'm going to ignore the negative. I really personally don't like having negatives on my triangles. Like I said in the previous example, it can work. I'm not saying people can't make it work, but it feels like there's more things you have to memorize. Why memorize more? Let's just use what we already know. So let's just use it as distance. Going left 12, well, that's why we're going in this quadrant, because we went left, but that distance is still 12. Up 5, this distance is 5. Get your hypotenuse. 5 squared plus 12 squared is your hypotenuse squared. Do your arithmetic. I mean, no, sometimes I do these a little fast, everybody. No shame. Take your time through these. If it takes you 2, 3, 4, 5 lines to get the answer, it's about doing it right. Don't try and rush through it. But 25 plus 144 is 169. That is a perfect square. And again, I'm in a triangle. I'm not getting the final trig value. I'll think of the positives and negatives when I get to the trig functions. So for right now, just like the triangles we did at the beginning in Unit 2, just make everything positive. So that angle in the second quadrant. Now let's go to work. Second quadrant, sine is positive. AS, it's the S quadrant, so sine is positive. I already know cosine and tangent will be negative. Again, the ASTC, that only deals with the primary, so we're in the S quadrant, sine is positive, the others are negative. Well, what are the values from this angle's perspective? Opposite over hypotenuse, we get sine is 5/13. Cosine, we'll do adjacent over hypotenuse. We already got the negative. If you hadn't, make sure you don't forget that, but then adjacent over hypotenuse. The quadrant gives me the plus or the minus, and then the triangle is how I get the numerical values. Similar for tangent, negative from the quadrant, 5/12, opposite over adjacent for the value. And now we fill in the remaining, so we've got cosecant. Again, everybody, creature of habit. Get your three primaries, do these in the same order, so it's always a quick match. Cosecant is the flip of sine, so I get positive 13/5. Secant is the flip of cosine, so I get negative 13/12. And cotangent is the flip of tangent, so I get negative 12/5. Let's do that one more time. Okay? Same type of problem. Let's see it again. So this time, let's say theta goes through the point 2, -1. And again, we'll evaluate all the trig at theta. And again, exact answers. Two, -1. Now we are in the fourth quadrant. 2 to the right, down 1. Remember, 2 to the right, down 1. Remember, notice every time I'm drawing triangles, whether it was word problems, now that we're, looking at the XY axis, I'm just drawing them to keep track of the sides. I am not trying to do anything with scale. I mean, maybe some people look at this and like, wait, shouldn't have this side been longer? 12 is more than twice the size of this. Sure, but that's missing the point. Because once I have my triangle set up, even if like this was supposed to be 12 and that's 5, it's just about being able to identify the appropriate sides. What quadrant, what's the opposite, what's the adjacent? That's the main thing that we need to keep our eyes on. So if you want a 2 and then down 1, that's fine, but it's really just your point is somewhere over here. So there's theta. There's my right triangle, always going to the x-axis. Alpha, the reference angle to the x-axis, that's what orients this triangle into opposite adjacent hypotenuse. I went 2 to the right, this is length 2. I went down 1, this is length 1, missing the hypotenuse. So similar to this one, do some work. 2 squared plus 1 squared equals blank squared. 4 plus 1 is 5. The square root of 5 is just radical 5. I mean, a tiny little thing I should also mention, again, some people are so trying to get this to scale and they end up making a tiny picture because they end up going, okay, there's 2, there's 1, and there's their triangle, and they can't draw anything. And you could exaggerate it if you need to. It's about making the triangle useful to you. Like I said, it's not about scale, it's not about size, it's about being able to clearly see what it is that you need, what it is that you want. So now I've got all 3 sides and I'm in the fourth quadrant. So I'm off and running. The fourth quadrant is the C quadrant, cosine. So cosine is positive, therefore sine will be negative. Negative what? Opposite over hypotenuse, 1 over radical 5. So I'll get negative radical 5/5 when I clean that up. Cosine, we just said we're in the cosine quadrant, so now we get a positive adjacent over hypotenuse, and I'll also clean that one up. Tangent is negative. Cosine was the only positive trig function in that quadrant, so therefore tangent is negative. Negative what? opposite over adjacent. So I get negative 1/2. And now the easy part, because the rest are just the flips. Cosecant, flip this, I get negative radical 5. Secant, flip this, I get positive radical 5 over 2. And cotangent, flip this, and I get negative 2. Of course, right, you could write negative radical 5 over 1, negative 2 over 1, but just the over 1 part, certainly not necessary. Okay, so we have really covered a lot so far, and like I said, I hope now we look at this, these problems look very, very different at first glance compared to a problem like this, but how similar it still is. Given some information, use that information for quadrant and right triangle, and then use that to get your trig values. So whether we did that here or here, very, very similar type of problem. Okay, now we move more formally back into our reference angles. I've been showing you them a lot, all these little extra triangles. Again, this was theta all the way around here, but just that is the little alpha. So we again talk about finding that our reference angles first. The definition is that the reference angle is always an acute angle, and it is always formed, specifically, I say you go to the nearest x-axis, but specifically, we're looking at the terminal side of theta to the x-axis. Now, they take a lot of time pointing out degrees, radians, how to find the reference angle. And they almost in the book, they point out, it's like there's 4 formulas depending on which quadrant. I would really hope that we don't have to memorize the formula. We should be able to look and apply this definition. So let's find reference angles for each of the following. Again, just a quick reminder, we already showed your reference angles. If your angle's in the second quadrant, there it is. Terminal side of theta to the x-axis. There's your terminal side of theta, there's the x-axis. This little one is the reference angle. There's your terminal side of theta, there's your x-axis, there's your reference angle. So now let's actually look at some measurements and find the measure of those reference angles. So let's start with number 1. Let's look at 152 degrees. Well, 152 degrees, I'm in the second quadrant. Again, I don't need a protractor. I'm not trying to make this too accurate. I just need to know I'm in the quadrant, which quadrant I'm in, so I could realize where my reference angle is, and this should point out how to find the value. Look at these two combined. If you take the regular angle and you include the reference angle, you have just covered half of the unit circle. That whole measure to this boundary is 180 degrees. So think about what we said about angle measure in the same way we think about measuring sides. If I know this big piece and I know the measure of this smaller piece inside the big piece, this other piece will be this minus this. Or other situations, you know this small piece, and then you know this piece, so the measure from here to here would be this plus this. We do the same thing with angle measures. All of this is 180. This is not, this is smaller than 180. How much is it short by 180? By this amount. So this reference angle will be 180 minus 152, which would be 28 degrees. And like I said, in the book, it's almost like they want you to memorize that. They say, well, if you're in the second quadrant, you should do 180 minus the angle to get the reference angle. I really hope you don't have to memorize that. We should be able to look and see it. Similar, let's go to number 2. I'm going to start these off with degrees, everybody. We'll come back and do some radians in just a few moments. So let's take a look at number 2. let's find a reference angle for 261 degrees. Well, 261 is bigger than 180, smaller than 270. I mean, it's pretty close to 270, but again, don't need to get this to be too accurate, just need the quadrant. So there's 261 degrees. This is the reference angle, just going back to the x-axis. Again, you don't pick which axis you go to. You have to go to the x-axis. What does this measure? Well, we're still using this x-axis, so the 180 is still coming into play, but this time, in the previous one, 180 was bigger than the angle we started with. This time, the angle we start with is bigger than the 180. So look at it, it's all about big and small. Here, 180 was the big. We took that whole 180 minus this piece to get this piece. Well, in this one, the 261 is the big angle. 180 is the smaller piece, but if you take away the 180 from the 261, this is what's left, and that's exactly what we want. So we would get 81 degrees for problem number 3. Problem number 2. Let's take a look at number 3. Let's take a look at, we'll go 200 and, let's keep it simple. We'll go 280 degrees. 280 degrees. Now I'm in the 4th quadrant. There's my 280. And this is the angle I'm looking for. Now, I mean, there are little things I should point out here very quickly. Some people do other rationalization like, okay, well, if this is 261, you're 9 degrees short from 270. But then you have to still think this is the angle you want. Well, this plus this adds up to 90. So again, there's little other things you could add or use to confirm your answer. But the easiest way should always be think about the angle you're given, think about the angle to the x-axis. So to the x-axis, you'd have to complete the full circle to get back to 360. So 360 is the big value, 280 is a part of that, and you're this far short of 360. So 360 minus 280, and this one would have a reference angle of 80 degrees. So let's keep going with that. We're still finding the reference angle. Number 4, let's look at 25 degrees. Well, 25 degrees is the first quadrant. This one's almost too easy that people miss it. When you're in the first quadrant, you're measuring from the positive x-axis, so that angle back to the x-axis is the exact angle itself. So again, it almost seems a little trivial that the reference angle, if you're in the first quadrant, is the same angle itself. But again, think about the definition. The definition is the angle to the x-axis, and this angle is already going right to the x-axis. We're not going across into any other quadrant. Okay, let's do a little more. And now let's start mixing some radians in. Let's look at the measure. Let's start off with 5 pi over 3. One thing I can still say, I have no problem with you converting. You convert this to degrees, you would get 300 degrees. Think about the 4th quadrant, right? So now you'd be looking at that's 300, this is what you're missing, and the answer would be 60 degrees. That's a perfectly good way to do it, and I would not give you a hard time if you converted. And again, that still works, as we keep suggesting that you can always make these little translations and work with degrees if that's what you're more comfortable with. But I should point out how to do it, and it's no different. It's the same thing, just instead of looking at this as being 360, so 360 minus 300, think of it as 2 pi. You would have to do 2 pi minus 5 pi over 3. Same idea, just like here, I did 360 minus 300. 2 pi is the same as 360. The 5 pi over 3 is the same as the 300. It's just all those little conversions. Get a common denominator. 6 pi over 3 minus 5 pi over 3 would be pi over 3. I want to point something else out, especially with the, how do I want to phrase this? If you go back to that reference angle chart, which I will bring back up in a few more minutes, that is those nice angles, the 30, 45, 60, the pi over 6, pi over 4, pi over 3, those are very common when we're looking a little deeper with common radian measurements. And what I'm trying to point out is that if you start off with a pi over 3, it's not a coincidence the reference angle is pi over 3. If you did 4 pi over 3, for instance, you'd be over here in the third quadrant, and then you would have to do 4 pi over 3 minus pi, and you'd still get pi over 3. If you're at 2 pi over 3 in the second quadrant, you would have to do pi minus 2 pi over 3, and you get pi over 3 again. So especially with those nice common angles, those common reference angles, the 30, the 45, the 60, as long as your fraction is reduced, pi over that denominator is your reference angle. Okay? So let's see that again. Let's look at number 6. Let's take a look at, let's go 4 pi over 5. Again, I'm perfectly happy again if you do your degrees, but let's just stick with radians for this one. 4/5 pi, 4/5 is less than 1 pi but bigger than 1/2 pi, so I know I'm in the second quadrant. So this is the 4 pi over 5 angle. All the way to here gets me to pi. This is what I'm looking for. In degrees, we would do 180 minus this to give you this, but that works out to pi minus 4 pi over 5. Pi over 1 becomes 5 pi over 5 with the common denominator. And like I was saying, this is not one of our common reference angles, but the same thing. Not too surprising, 4 pi over 5 has a reference angle of pi over 5. And let's just do one more, and then we could start to tie this in together with the trig functions at any angle, and we could finish this up. Finish unit 3. So number 7, let's take a look at, let's do 10 pi over 9. Again, convert. If you do degrees, you would get 200 degrees. Third quadrant, the reference angle is 20 degrees. In radians, 10/9, bigger than 1, less than 1 1/2. So I know I'm in the third quadrant. But just back to the x-axis this time. So 10 pi over 9 is big. Pi is a big piece of that, and the piece we want is the difference between those two. So 10 pi over 9 minus pi, which pi over 1 becomes 9 pi over 9. And 10 pi over 9 minus 9 pi over 9 would give us pi over 9. We had 20 degrees if we did it in degrees, and pi over 9 as radians is the equivalent of 20 degrees. Okay, so why the big deal with reference angles? Why are we spending this time doing this? Because now with the trig functions, and this is not just the final evaluation, we should be able to take any trig function and we should be able to rewrite as a function with a positive acute angle. And the way we do that is by combining the trig function, the plus or minus from its sign, and the appropriate reference angle. So for instance, that sounds pretty complicated, and it almost seems like if you go through, this is 3.3, this comes up on, what is that, page 59, I believe it is, 58. 58 in the book. It's like they give you this step process, but again, it's kind of what we keep doing. It's about take the angle, which quadrant are you in, get the appropriate plus or minus, knowing from the quadrant and the appropriate trig function. But then the second part is rewrite that trig function in terms of its reference angle. So if we want to do that and we start number 1, sine of 110 degrees. How do we do that? Well, 110 degrees is in the second quadrant. I know sine is positive in the second quadrant, so I know I get a positive. And then it's kind of like the y value here, symmetry would be the same as the y value here. So as long as I get the plus or minus in the right place, the sine at the reference angle would give you the same value as sine from the whole angle. So what's the reference angle? Well, this is 110, this is 180. That gives me a gap of 70. So sine of 110 would be the same as positive sine of 70. Now, they don't want you to evaluate. Several of the problems in the book, they specifically say do not evaluate. But I do want to tell you, you could easily confirm this on your calculator in just a moment. Just to confirm you get the same thing. So if you start with sine of 110, you see that ugly decimal. But now if you do positive, which I don't have to enter that, but if I do sine of 70, same ugly decimal. And again, that all comes up because going back to that original unit circle and that definition, sine is y, cosine is x, it's all about symmetry. That if this is a nice angle in the first quadrant, well, if you go to this point here, you're basically getting the same triangle here that you got here, but x would be negative, y would be positive. So the cosine value here, same value, just that it's negative, and the y is exactly the same. If you go down here into this quadrant so that this angle is the same as this angle, similar. The x's and the y here, well, this x is the same as this x, which is negative the value of this x, but the y value, same distance below as it is above, but the fact that you went below is just another confirmation that y is negative. If it sounds like I'm talking a little bit in circles, I kind of am. We keep saying the same things in different forms, but it all just comes back to why this is the same thing. That if you take the reference angle, that will give you a positive acute angle, but then we have to take care of the plus or minus on our own. So let's do a similar one with sine. Let's stick with sine for another moment. Let's take a look at sine of 200 degrees. Well, now 200 degrees, I'm in the third quadrant, bigger than 180, smaller than 270. So this would have a reference angle of 20, and two things. I'm in the third quadrant, I know sine would be negative, and now with the reference angle, negative sine of 20. Sine 200, that has the negative built in because the angle, the calculator knows what quadrant we're in. But now if we clear that and do negative sine of 20, not a coincidence, it's the same thing. So like I keep saying, they want this is your final answer. And in just a moment, we're going to solve these even further. This is where we'll bring that reference angle table back into the picture in just another moment. But even when we get there, part of, you have to show me some work. So what can you show me? These are good things to show me so that you're not just pulling your answers off a computer, getting answers elsewhere, that I could see your understanding where it comes from. So this is a good exercise, even for when we take this a step further in a few more moments. But let's keep going here. Let's do a few more, and then we'll wrap up this section with the full big problems that we keep mentioning. So next, let's take a look at cosine. Let's throw a radian measure in here. Let's do 7 pi over 5. Keep saying it, degrees, radians. I don't mind one way or another. So if we look at 7 pi over 5, 7/5, bigger than 1, smaller than 1 1/2. So this is pi, this is 7 pi over 5. When I subtract, you will get 2 pi over 5. That's where I was, again, up here, that this is exactly pi over 5 with the nice reference angles, pi over 3, pi over 4, pi over 6. That works like a charm. But here it's not just pi over 5, it's 2 pi over 5. So make sure you understand the process. And again, no problem if you want to convert that to degrees. So we got our reference angle. The fact that we're in the third quadrant, cosine should be negative. Negative what? Negative cosine of 2 pi over 5. Reference angle goes inside, and it's the same trig function. It's just the extra part of figuring out the appropriate plus or minus to go with it. Still certainly can confirm that. Just make sure you go to radians, that's all. So now if I do cosine 7 pi divided by 5, negative, kind of ugly decimal, negative cosine 2 pi divided by 5, negative, same ugly decimal. That's a nice little clever way just to confirm. Just to realize though, now I'm in radian mode. I kind of like to leave my calculator in degree mode. That's just me though. I still strongly recommend every time, always make sure you keep confirming. Is this correct? Is this, how do I want to phrase this? Is this correct? Am I in the right mode, right? Every time you go to use the calculator, it should be a really just habit. Am I in the right mode? Yes, I am. And then go through and do your computation. And sorry, buddy, this is number 3. That was number 2, so that was number 3. Let's do a couple more. Number 4, let's take a look at tangent of 312 degrees. 312 is in the fourth quadrant. My reference angle is what it takes to get back to 360. So 360 minus 32, I will get, 360 minus 312, sorry about that. That'll give me 48. And the fact that I'm in the fourth quadrant, I know tangent is negative. Last one, number 5. Let's take a look at cosecant of, let's go 217 degrees. Cosecant connects to sine. So cosecant is positive or negative wherever sine is. So treat the plus or minus in the same way. 217, third quadrant. 217 minus the 180 would give us 37 degrees. And in the third quadrant, sine would be negative. So cosecant would also be negative. Okay, and now we wrap this up, everybody. This is another fairly lengthy unit. A lot of different facts here, and here we are getting a lot of different problems. So, and I always say it, one of the biggest keys, certainly understanding your facts is a huge part to doing well and keeping up with this, but getting the practice, getting the experience, it's a very, very big part in being prepared for any quiz and test and making it a regular part of your habit. Familiarity with your instructions really helps a lot. So this next one, we are going to find exact values. And we're going to find these exact values doing what we've been doing essentially, but now I'm going to bring that chart back up. We've got 0, 30, 45, 60, 90 as our common reference angles. And in radians, that's 0, pi over 6, pi over 4, pi over 3, and pi over 2. I'm going to do sine before I do cosine. Again, some people just have these values memorized, but if you forgot, you have that nice little trick. Everything starts divided by 2, the square root of 0, square root of 1, square root of 2, square root of 3, square root of 4, all over 2. Clean those values up, then same values opposite order for cosine. And when you're done, those are the values you get for sine, So therefore, when you reverse the order, these are the values you get for cosine. How are these supposed to help? Well, let's see. Number one, let's start off looking at sine of 210 degrees. If this is where I can't say it enough, everybody, you give me an answer with no work, I gotta take points off. I understand that several people can think their way through all this in their head, but you have to show me something. So what can you show me? Well, you can do exactly what we were doing on the previous page. The way to use this chart is to do exactly what we were doing here, except when you're done with these problems, you'll have these angles that are left, the reference angles, will be one of these reference angles. So that's how we could finish using this chart. So sine of 210 in the third quadrant, 30 degrees as the reference angle. And honestly, if you draw this, I'm okay with that. Show me your chart, show me this picture, and now I could understand when somebody just says, okay, well the answer is -1/2. Because you're showing me in the third quadrant, so you don't have to write me a sentence. I could understand that you're getting the negative because you clearly showed me the quadrant. And there I can assume you knew how to deal with the plus or minus appropriately. And then the second part is that the reference angle was 30, so you looked at sine of 30, and that's where you get the value 1/2 from. This may seem a little surprising, but this is still incredibly similar to those trig value problems we were doing earlier, because we still have to do something to think about the plus or minus from the quadrants. But then the second part, when we got the value, those problems we're all using some right triangle that we drew or was given to us. Here, we're going to use the reference angle chart with the correct reference angle. So that's how we're going to get started here. Number two, let's keep going here. Let's take a look at sine, and stick with sine for just one more, of 750 degrees. Well, some more angle facts. What quadrant are you in? Well, let's not forget, that's too big. We like our angles between 0 and 360, so this is not. So before I do anything in this problem, oh, I'm sorry, very quickly, right back here, I showed you that this is enough and I would take this as a final answer, but I think for a lot of people, I'm sorry, I meant to mention this, that's a good in-between step. Again, doing exactly what we were doing right here. First, taking that trig function, getting the appropriate plus or minus, and writing it in terms of its acute angle, which is its reference angle. And then on the second part, the negative pushes along, and sine of 30 gives you 1/2. I don't need the picture and this. Either one would suffice. But like I said, get into a habit. You got to show me something here. Otherwise, it really could just be a lot of more button mashing. And this is unfortunate because there are some calculators that, like normal calculators wouldn't give you this as a fraction. But some of the newer calculators, because it's a program value, they could actually identify that. So again, I need to see some work. But now back to number two, this angle is too big. So what do we do in all the other cases? We subtracted until we got to an angle that we do want. Oops, I'm sorry, I wanted this to be 780. Sorry about that. Sine of 780. We subtract 360, and we're left with 420. That's still too big. So subtract 360 again, and we're left with sine of 60 degrees. Now, some people would say, well, wait a sec, they feel weird here, but realize this is just a nice thing. You're already in the first quadrant. I mean, this goes right off the chart. Sine of 60 is radical 3/2. You may feel like you skipped a step, but that's something we pointed out already. This is already a first quadrant angle. In the first quadrant, the angle itself is the same as its reference angle. And in the first quadrant, all trig functions are positive. So if you're lucky enough to just have one of these angles either automatically given to you or through coterminals that it ends up being one of these angles, it should actually make this problem a little bit easier. Okay, let's keep going. Number 3, let's take a look at cosine of negative 225 degrees. Well, negative 225. Pretty much the same situation we had here. This angle was too big, so we subtracted 360, and one time didn't do it, so we did it a second time until we got a nice angle. Here, this angle is too small because it's negative, so I'll add 360 to it, and I'll get 135. Now, I only had to add once here. Maybe we have to add twice just to go getting into that nice 0 to 360 degree window. And now that we're there, back to this idea. 135. I'm in the second quadrant. The reference angle is 45. And for some, that's enough. You show me that. I know you could finish that because quadrant 2, cosine is negative in that quadrant. And at 45 degrees, cosine has a value of radical 2 over 2. That certainly works, but others, like I keep saying, they like this part. So they acknowledge before they go from here to here, whether they draw this or not, that cosine will be negative and that its reference angle is 45, so negative cosine of 45, and then we still get to that same answer. Let's continue here. Problem number 4. Let's take a look at tangent of 5 pi over 6. 2 quick options. Some people don't like the radians, so they make it degrees. Again, take your time, just like I said, with some of the other problems with like Pythagorean theorem, converting radians to degrees. If it takes you 2-3 lines to do that, take your time. But if you make that conversion, that's fine. You'll end up getting 150. And no matter which way you want to treat it, you'll get the same answer from here. So let me do it this way first. Tangent of 150. Well, in the second quadrant, that would leave a reference angle of 30, and tangent is negative in that quadrant. So they go negative, and for tangent of 30, they'll do sine of 30 divided by cosine of 30. That's one way. But again, clean up this fraction at the end. Negative 1 over radical 3 becomes negative radical 3 over 3. Again, take your time, but make sure you clean that up. So that's a perfectly good option. Some people right off the bat, now this doesn't matter if you convert it to degrees or not, instead of working in terms of tangent, some people would right off the bat go directly to sine over cosine. Sine would be positive in the second quadrant at reference angle 30. Cosine would be negative. And the only difference when you plug in, you technically get your positive here, your negative here, as opposed to the negative out in front, but it's all the same after you clean it up. So kind of some minor little alternatives, minor little differences in the way one student does it and another, but it's all staying using the right facts to get a right answer. Well, what about in radians, you ask? No big deal. This is 5 pi over 6. This is pi. So the reference angle, pi minus 5 pi over 6, would be pi over 6. And no surprise, pi over 6 and 30, that those match up. It's the same thing. Again, it's all the same thing, just whether you convert it or not. Let's keep going. Still want to get a couple more. This is another one of those places where some people, it's like they instantly get it. It makes a lot of sense. Other people just need a few more examples to just see some of the possibilities. To, again, make sure you're not jumping the gun. And what I mean by that, you're not looking at one problem and making a grand generalization that'll get you in trouble at another problem, that you're seeing and identifying the right pieces. So number 5, let's take a look at cosecant of, let's do this one of 300. Cosecant of 300 degrees. Well, a lot of people, first things first, again, get rid of the cosecant, the secant, write in terms of sine and cosine. Now, 300 leaves us we're in the fourth quadrant with a reference angle of 60. Sine is negative in the fourth quadrant, and we'll evaluate at that reference angle 60. So 1 over negative sine of 60 is the radical 3 over 2. So I get negative 2 over radical 3, and I rationalize. So some of those you can see. Go back to problem number 1, or, some of the sines and cosines. Those go directly with the chart. So those are certainly the ones that people, again, can tend to do a little bit faster, but make sure you show me something. Something for the quadrant, the reference angle, so I could clearly see you're piecing it together. For some of the other ones, if it's not sine or cosine, well, just doing some of the rewriting, that's almost forcing you to do some steps. Notice, I don't have tangent on my chart here. So the way that you get this answer is by doing sine over cosine. So by showing me that, just showing me a little bit, that little bit is all I need to see. So even if you don't show me all 6 of these steps, but by showing me a couple, I know, again, you're not just using some online resource and that you're showing me that you understand this process. And over here, again, same thing. Just by doing a little bit of the 1 over and actually showing me a little bit of work, it's an easy way. What's enough? It's not that you have to show me a lot, but just a little bit. You don't just jump from here to here. That, to me, either you're not showing me your work, which is, we're going to say that on all of our tests and quizzes. Proper work must be shown. And if you ever question about how much is enough, you can always ask. But if you just jump from here to here, you're going to lose points. So again, do you have to show me all of this? No, but at least some of this to show me your thought, your train of thought, and that you're doing it the right way. Okay, so let's wrap this up, everybody. Let's just do 2 more. Let's get one more radian in here, number 6. Let's take a look at secant, and let's go secant of, let's do 11 pi over 3. Yeah, let's do secant of 11 pi over 3. Well, first thing, you may not see it as quickly because it's in radians, but that angle is too big, just like 780 was too big. 11 pi over 3, well, 6 pi over 3 is 2 pi, so 11 pi over 3 is too big, so I will subtract 2 pi. When I do that, I will get 5 pi over 3. 11 pi over 3 minus 6 pi over 3 will give me 5 pi over 3. Again, the little things, do you now jump and make that 1 over cosine? Do you get the reference angle next? These little things, that's not a big deal. 5 pi over 3. Again, you could have always converted to degrees, but I want to stick with radians here, just to, again, give you a little bit more. But if you make it degrees, no big deal. It's 300. You would have 1 over cosine of 300. 5 pi over 3 is the fourth quadrant. 5/3 is bigger than 1 1/2, but smaller than 2. So this reference angle, 2 pi all the way around, 5 pi over 3 just to here. So 2 pi minus that 5 pi over 3 is pi over 3. The fact that I'm to the right, cosine is still positive in the fourth quadrant. The x would still be positive here. So now cosine of pi over 3, I get 1 over positive 1/2, which gives us a final answer of 2. Okay, and last one, let's do one more. Number 7, let's take a look at cotangent of, let's do negative 120 degrees. Well, cotangent is 1 over tangent, but for a lot of people, they might already jump to the cosine over sine definition. The negative angle, well, at least it's degrees, but let's make it positive. So we would get 240 degrees. So I'll get cosine of 240 over sine over 240. 240 is in the third quadrant. So the reference angle is 60. Negative cosine of 60. Sine would also be negative at 60. I mean, little things. If you did it 1 over tangent, tangent is positive here. But look, it still works out. A negative divided by a negative will end up being a positive. And then cosine of 60 divided by sine of 60. And this is, honestly, it's the exact same thing you had up here. Just a coincidence. I mean, again, you see we keep using the same reference angles over and over. So it's not too surprising that we get some of the same values. But again, still need the work. Still need to confirm, clean this up. You'll end up getting positive radical 3 over 3.